Hello, astronomy class. Today we're going to be talking about the Big Bang Theory. So we've talked about several things that lead cosmologists to believe that the universe is expanding, and that because it's expanding, we can kind of infer that there must have also been a time where it's much smaller. But I'll get to that in a second. So Big Bang Theory. Remember when we use the word theory in science, we're not talking about, oh, this is a hypothesis or this might have happened, I guess. It's not a guess. When we say the word theory in science, we mean it's a collection of facts that lead us to one large conclusion or maybe multiple conclusions. Like, for example, if you took my earth science class, tectonic plate theory is a theory about the earth being split into multiple pieces. Tectonic plate theory has lots of different consequences, like earthquakes and volcanoes and moving continents. Big Bang Theory primarily talks about um, kind of how our universe came to be. But before we get into that, let's just kind of step back and talk about what things scientists use to describe the Big Bang Theory. So we just finished a chapter on universal expansion. So we know that by looking at galaxies far, far away, that the universe is expanding. It's kind of a hard fact to refute. Um, in every direction we look in the sky, if we look deep enough, we see these galaxies that are moving away from us. And the farther the galaxy is away, the faster it's moving, which infers that every galaxy or every galaxy supercluster is moving away from each other, leading us to this idea of universal expansion. So that's the first thing to know. The second thing to know is that cosmologists, remember, cosmologists are scientists who study the universe, are pretty confident of the composition of the universe. By looking in all directions, we can kind of make a pretty good estimate of what the universe is made of. So, according to this graph from NASA, 4.6% of all the universe is made of atoms. Atoms is everything that we can see and touch, and which means the rest of the universe is made of things that we can't see and touch, which is pretty crazy to think about. Dark matter is at 24%, and dark energy is 71%. Dark matter, you remember, is the stuff that is kind of the idea that astronomers invented to account for the fact that galaxies don't spin that the way that they thought they should. That there's some missing matter in there. So dark matter, that's what dark matter is. We can't see it or detect it or touch it, but we know something is there. Dark energy is something that we didn't talk about yet. Dark energy is the unknown force that is causing space to be created. Remember, we said universal expansion yesterday, that universe is expanding means that there is new space being created that allows the universe to expand. Well, in order to create new space, you need some energy to do that. Well, dark energy is what we call that. We don't know what it is, but we know it's there. Um, so, taken into the fact that we know the universe is expanding and we know what more or less what the universe is made of, or at least how much energy there should be, we can kind of think, okay, if the universe is expanding, getting bigger now, that means at one time it must have been smaller. And I guess if we go back in time more, it'd be smaller, and go back in time more, it'd be smaller. And so, based on how fast the universe is expanding now, and some other facts that I won't get into, cosmologists have estimated that 13.7 billion years ago, the universe was almost infinitely dense. In other words, all of the matter, including you and me, and all of the stars and galaxies, were all compressed very, very tightly together. Not into one point because, well, we can't really say one point because the universe could possibly be infinite. So it could be just the universe at one point could have been an infinite uh, glob of hot, dense matter. But according to cosmologists, as far as time is concerned, that didn't last very long, and all of that matter kind of spread out or rapidly expanded into space. So even though this theory is called the Big Bang, there was not really a bang. It was just a rapid expansion. The Big Bang is actually kind of a misnomer. Um, when the theory was first came out, it didn't really have a name, and an astronomer went on the radio and described what it meant. He described the process as the Big Bang. And even he knew that it wasn't really a bang. It was just a rapid expansion of space that allowed material to spread out and cool down, form galaxies and stars. But the name Big Bang kind of stuck. So that's what the Big Bang is. The Big Bang is the idea that all the matter in the universe was scrunched down into a very, very tight space, and then it rapidly expanded until it cooled down enough to where atoms could form, and that atoms could form stars, and stars could form galaxies. Although I might have that backwards. Galaxies might form before stars, but different topic for a different time. Um, so that was the theory. But when the theory was first published, scientists didn't have a whole lot of evidence to back up this fact until um, the CMB was discovered. So the CMB that stands for cosmic microwave background. A lot of us know what microwaves are because we cook with them. Um, if you remember our chapter on light, light comes in lots of different flavors or colors. And like, for example, the lowest energy light that our eyes can see is red light. But if you keep on going down lower in energy, you reach radio waves. And lower than radio waves are microwaves. Microwaves. So I think I told you, we went over before that our bodies, or everything that has heat, emits light. So our bodies right now, my body's emitting light. My body's emitting infrared light, which is the light just before red energy. We can't see infrared, but it's there. We can use infrared cameras to see that. And even colder than infrared light would be radio waves, and even colder than that would be microwaves. So this CMB, this cosmic microwave background, if we look far enough into space, farther than the farthest galaxies, in all directions, we can see what's called the cosmic microwave background. It's called that because it's kind of like the background of space. You have a background image on your phone. Well, if we look far enough to space, we see this. We see this pattern. So the blue, red, and greens here are just kind of showing, well, there's a few hot spots, a few cold spots, but basically it's all one temperature. That's about 3 degrees Kelvin. This isn't something we talked about in class before, but the coldest temperature that you can theoretically reach is 0 Kelvin, because 0 Kelvin is the temperature at which atoms cease to vibrate. So if we see this weird pattern everywhere in all directions that we look in space, we see this, it's kind of like, this is kind of like the barrier. We can't see past the CMB. And what the reason that cosmologists use this as evidence for the Big Bang, they reason that, well, if the universe was at one point so hot and so dense that it just kind of made this big hot blob, well, that's not something you can see through. Like, you can see through a piece of glass, or you can see through air. But if something was hot enough, you wouldn't be able to see past it. Um, and so that we could so what they reason is that this CMB is what the universe would have looked like a few seconds after the Big Bang, or a few seconds after the initial expansion of space. Um, but that even this boundary, even the CMB, is expanding with the rest of space. And so that light, that very, very hot light, as it's traveling to Earth, has become redshifted so much that it has redshifted into the microwave uh, spectra of light. So if you have any questions about that, I'd be glad to talk to you about that. And if you're curious about the evidence that cosmologists use for the Big Bang, I encourage you to research it yourself. And this piece of evidence in particular, just go onto YouTube or Wikipedia, look for cosmic microwave background, and it's something that you will see come up in CK12 today, and it will come up on a quiz today too. Um, that's what the Big Bang is. The Big Bang theory is a unification of lots of different facts that cosmologists use to reason that at one time the universe must have been very fairly tightly put together, so tight that not it was too hot for atoms or stars or anything else to form. It's just one big hot mess. And then, for some reason, we don't know why, the expansion began, things began to cool down and we could actually form matter as we know it. So that's what you're going to learn about today in class. And you'll also learn about a couple of theories about how the universe may or may not end. But don't worry, those are billions of years in the future. So that's all for now. I'll talk to you later. Bye.